In section 6.2, we'll review transformations that you did in Algebra 2, transformations of graphs of functions, and we'll also introduce you to a new transformation. I'm going to do them by table of values. You may not need to use table of values on all of these, but especially for the combined transformations and also for those that are new to you, I suggest that you use a table of values to make sure that your work is accurate. All right, we want to consider the graph of y equals f of x that's shown at the right. We can make a table of values from this graph. So, for instance, when x is -3, f of x, or y, is 0. When x is -2, f of x is -1. When x is -1, the y value is -2. At 0, the y value is 0. At 1, the y value is 2. At 2, the y value is 0. At 3, the y value is -3. And at 4, the y value is -2. So that's a sampling of the function values. Those are all the x values that are integer values. So what do we know about f of -4 though? F of -4, we can't find an x value of 4. F of 5, we can't find an x value of 5 that lies on the graph of the function. So these are going to be what we call undefined. And that means that those x values are not acceptable values in the domain of this function. And so that means that the domain of the function is all of the x values for which f of x is a defined value. So -4 and 5 are not in the domain because f of those values is not defined. Now, let's talk about the number 2.5. There is a y value when x is equal to positive 2.5. So 2.5 is in the domain, yes, because f of 2.5 is -1.5. There is a y value on the graph associated with x equals 2.5. The domain of this particular function is stated as -3 is less than or equal to x is less than or equal to 4. So all of the x values have to fall in that range. And so we listed the ones that are integer values, but all those ones in between the integers are also included. And that's why we can't just say -3, -2, -1, 0, 1, 2, 3, 4. We have to include all of those in between, and the way to say that is with an inequality. All right, so let's get down to transformations. This is a graph of y equals f of x, the same graph that's above. And so it's included for your reference. And we are going to create a table and graph each related function. So if we're thinking about what happens when we plug in an x value, the first thing you have to do for this particular equation, y equals -f of x, is you have to take f of x, and then you have to take the opposite of it or multiply it by -1. Well, we know all those values for x and f of x. We just listed them in the table above. So when x is -3, f of x is 0. For -2, f of x is -1. For -1, f of x is -2. For 0, y is 0. For 1, y is 2. For 2, y is 0. For 3, y is -3. And for 4, y is -2. Now, all that's left is to take the opposite of each of those f of x values. So -1 times the f of x value in the column to its left is 0. So we're just going to take opposite. So that'd be +1, +2, 0, opposite of 2, 0, +3, and +2. Now we can graph each of those values. So we're using the x column here, and the y for the new function is in the right column. So those are our set of ordered pairs. -3, 0, -2, 1, -1, +2, 0, 0. Notice what's happened so far if we connect those points. And then 1, -2, 2, 0, 3, +3, and 4, +2. And you can observe that this one is a flip over the x-axis, or a vertical flip. All right, let's take a look at a transformation you haven't seen before. This is y is equal to the absolute value of f of x. So we're going to plug in our x and our f of x values into the table, same as we did before. It just so happens we're using the same function for each of these questions, but we don't necessarily have to. So we have -3, 0, -2, -1, -1, -2, 0, 0, 1, 2, 2, 0, 3, -3, and 4, -2. And then our last column is going to be the absolute value of f of x. So we just need to take an absolute value of all the numbers in the second to last column here. Absolute value of 0 is 0. Next one is 1, 2, 0. The absolute value of our positive numbers is still positive. And then 3 and 2 at the very end. All right, let's graph those. -3, 0, -2, 1, -1, 2, and 0, 0. This first part is looking much like what we saw above. The next part of the graph, 0, 0, 1, +2, and then 0, 0. So the graph for the next part was left alone. And then we have 3, 3, and 4, 2. The next part was reflected. You might recognize what's going on in this transformation. The parts that were already above the x-axis stay where they are. In other words, the parts that had positive y values already stay positive. The parts of the graph where the y values were negative become positive y values, and therefore the graph gets reflected above the x-axis. But it's not an entire reflection, just the part that was below the axis. All right, let's take a look at the next one. Y equals 2 times f of x. So we have x, f of x, and final column 2 times f of x. We can plug in those x, f of x values, and as we start doing some that are more involved, I'm going to use one less value. You notice I've done -3, 0, and I've usually used -2, -1. There's not really a dot there, and that's not because there's not a point there. The reason there's not a dot there is just because the graph doesn't really turn there. So the graph doesn't do anything interesting. We don't really probably need to graph that point. So let's skip to -1, -2, 0, 0, 1, 2, 2, 0, 3, -3, and 4, -2. The last column is produced by taking 2 times the f of x values in the second to last column. So 2 times 0 is 0, and so on. Multiply all those by 0. -3 times 0 is -6. -3 times 2 is -6. -2 times 2 is -4. So we have -3, 0, -1, -4, 0, 0. So here's what the first part of the graph looks like. And then we have 1, 4, 2, 0. There's what the second part looks like. And then finally 3, -6, and 4, -4. So there's the last part. You'll recognize this one as a vertical stretch. Notice the points that are on the x-axis stayed where they were. All right, let's check out the next transformation. We're going to start it exactly the same way with x and f of x columns. And then our final column will be 1/2 times f of x. I think you can probably guess what this one's going to look like. So starting with -3, 0, -1, -2, 0, 0, 1, 2, 2, 0, 3, -3, and 4, -2. Now all that we need to do is multiply that second to last column by 1/2. So just take half of each of these values. Half of -3 is -1.5. Half of -2 is -1. So we have -3, 0, -1, -1, 0, 0. There's the first part of the graph. 1, 1, 2, 0. There's the second part. 3, -1.5, and 4, -1. There's the third part. This is a vertical compression rather than a stretch, or a vertical shrink if you want. Let's take a look at one more with a single transformation, and then we'll move on to the ones that are just a little bit more involved. So we have x and f of x columns, and the y's for this new function are produced by adding 2. And I was going to skip over -2, right? So -1, -2, 0, 0, 1, 2, 2, 0, 3, -3, and 4, -2. And then to get the last column, we're simply going to add 2. So we have -3, 2, -1, 0, and 0, 2. Second part of the graph, 1, 4, and 2, and you're going to notice that I made a boo-boo in this last entry in the column. So I forgot to add 2 to that particular value. So that should be 2. So we have 2, 2. Here's the next part of the graph. And we would notice that probably if we graphed it and saw that one point was out of place. And then we've got 3, -1, and 4, 0. So this is just really a vertical translation where the graph is shifted upward too. Right, now let's take a look at a combined transformation. We're not going to use any more columns because I don't really think that you need to. We're just going to have our x and f of x for reference. And once we've got those columns filled in, the last column will be 2 times f of x plus 1. So we're just going to take the second to last column, multiply it by 2, and add 1, which I don't think you need 2 separate columns for. So 0 times 2 is 0, plus 1 is 1. 2 times -2 is -4, plus 1 is -3. And same value when we do 0, when we work with f of x equals 0 all 3 times in this graph. 2 times 2 is 4, plus 1 is 5. 2 times -3 plus 1 is -6 plus 1 is -5. 2 times -2 is -4 plus 1 is -3. Okay, so we've got -3, 1, -1, -3, and 0, 1. Here's our first part of the graph. And then we have 1, 5, and 2, 1. And finally, 3, -5 and 4, -3. There's the final part of the graph. So you'll notice some things that are going on here. It looks like we did two things, right? We stretched vertically and we also shifted up 1. You think about our trig graphs, this looks a lot like where our midline was. Our midline just moved up 1. Those were all the points that were originally on the x-axis. Okay, so that's shifted up 1. All right, let's take a look at some other types of functions. F of x equals x squared minus 4. This one we should be able to do a table of values for pretty easily. I want to use enough values to give us a really good picture of what this looks like. For some of the transformations, if you don't use enough points, you won't see the full picture. So I'm going to use all the way from -3 to 3 for y equals x squared. And the f of x values are just x squared minus 4. So square and subtract 4. That's going to be 9 minus 4 is 5. 4 minus 4 is 0. 1 minus 4 is -3. 0 minus 4 is -4. And the positive values give us the same y values as the negative ones, because squaring a negative number and squaring a positive number give you the same result if they're opposites. So let's graph these. -3, 5, -2, 0, -1, -3, 0, -4, 1, -3, 2, 0, and 3, 5. You remember the thing about this parabola, though, is it does continue beyond the graph, so I'm going to go ahead and put those arrows on the end just to indicate that. And we can do a y equals f of x plus 2 by table of values. We already have the x and the f of x columns from the previous part of this question. And we're simply going to add 2 to each one of these for the final f of x plus 2 column. That's going to give us 7, 2, -1, -2, -1, 2, and 7. So now let's graph some points. -3, 7 we're not going to be able to graph. That one was off our grid. So -2, 2, -1, -1, 0, -2, 1, -1, 2, 2, and that's it. The last one doesn't fit on the grid. And this is just a translation up to of the previous graph. All right, let's try y equals -f of x plus 1. Let's plug in those same values, -3, 5, -2, 0, -1, -3, 0, -4, 1, -3, 2, 0, and 3, 5. And for the final column, we're going to take that second to last column, take its opposite, and then add 1. So -5 plus 1 is -4. The opposite of 0 is 0, plus 1 is 1. 3 plus 1 is 4. 4 plus 1 is 5. 3 plus 1 is 4. 1 and -4. Finishing out the rest because we get some repeat values. So -3, -4. -2, +1. -3, 4. 0, 5. 1, 4, 2, 1, and 3, -4. So now let's connect those, and you'll notice that this one had a shift up, and it also had a vertical flip in it. Last one. This one is that strange transformation that you haven't seen before, and so for this one, it's going to be especially important that we use a detailed table of values. So x, f of x, and the absolute value of f of x. And to get that last column, we just simply need to take the absolute value. So absolute value of positive numbers and zeros doesn't do anything to those values. We take the opposite of the negative values though. So now we have negative 3, 5, negative 2, 0, 1, negative 3, and 0, 4, 1, 3, 2, 0, and 3, 5. So remember what we talked about before. This graph took the part of the original graph that was below the x-axis and flipped it above, and left the part that was already above, so that now all y values are non-negative. Now we're not going to see a lot of trig, but you'll see a little bit of trig from time to time just so we remember some things. In this graph, h of x is equal to sine x, and we should know our points for the parent function sine of x. X has to be the angle, so 0, 90, 180, 270, 360 would be good values to use. And then our y values are h of x is equal to sine of x. Sine of 0 is 0, sine of 90 is 1, 0, negative 1, 0. So this is our parent function, 0, 0, 91, 180, 0, 270, negative 1, and 360, 0. So you recognize the shape of that sinusoidal function. The graph doesn't really stop there. The graph does go off to the side there, but I'm going to leave that in 2 colors so that you can see one cycle, and you can also see that it does go beyond that one cycle. All right, in our next table, we've got y equals negative h of x. So we need columns x, h of x, and negative h of x. X, h of x, those are just our parent points. So those would be 0, 0, 91, 180, 0, 270, negative 1, 360, 0. To get our final y column, we just need to take the opposite of that second to the last column, opposite of all the h of x values. So that just gives us 0, 0, 90, negative 1, 180, 0, 270, positive 1, and 360, 0. There's one cycle. The graph really does go beyond that. So that one's just a vertical flip. All right, let's check out this next one. Y equals 2h of x minus 1. Same reference points. And then for the last column, we're just going to take 2 times each h of x and subtract 1. So 2 times 0 minus 1 is negative 1. 2 times 1 minus 1 is 1. 2 times negative 1 is negative 2 minus 1 is negative 3. And then 2 times 0 minus 1 is negative 1 again. So we have 0, negative 1, 90, comma 1, 180, comma negative 1, 270, comma negative 3, and 360, comma negative 1. 1 cycle, but I'll indicate that it goes beyond that. And you'll remember some things about this. Remember that discussion we had about the midline. The midline is right here at -1. That's our vertical shift. And the amplitude is 2. That's our vertical stretch. Okay, last example. We have y equals the absolute value of h of x. So another quick table. X, h of x, and the absolute value of h of x. 0, 90, 180, 270, 360. And the corresponding y values. And now we're just going to take their absolute values. The beginning of the graph looks exactly like it did before because it was already above the x-axis. The next part of the graph, however, is going to be, instead of below the x-axis, it's going to be above. So this is kind of interesting. Graph just keeps bouncing off of the x-axis and going on top of the x-axis. It is important to note that this is like a sharp turn right here in the middle, though. It's not a smooth transition because that part of the graph that was below got reflected above. Well, that's it for the lesson.